Now, this is part 3 of our review for the regions of Algebra 2 for January 2017. So, right here on question 21, this is where we left off. So, now notice here that in question 21, we have the following. It says, Joelle has a credit card that has a 19.2 annual interest rate compounded monthly. She owns a total balance of B dollars after a month. And we're going to assume that she makes no payments on her account. And it says that the table below, it illustrates pretty much the scenario that we have here. Now, the question is, over which interval time is her average rate of change for the balance on her credit card amount the greatest? Now, there's a key word here, and that word is the rate of change. Because here, the average rate of change, we're pretty much going to be asking what is the slope between certain points here. If we want to know the average rate of change for the balance for the following options, we're going to be looking at the slope because slope is rate of change. So we're going to be looking at slope for the following 4 options, and we're going to see which of those 4 options gives you the greatest slope because we're looking for the average rate of change. Now, if you don't remember the formula for the slope is going to be y2 minus y1 divided by x2 minus x1. Okay, so now let's look at different options. Let's look at in option 1, which is that right here. It tells you that we want to know what is going on between month 10 and month 60. So between month 10 and month 60, let m be the x's, okay, and let b be the y's. So now if we use our formula, we're gonna get y2 minus y1. So we're gonna have 25. So let's call this y2. So we're gonna have 2591.90 minus y1, which is gonna be 1172, divided by x2, which again m's are my x's. So here we have 60 minus 10. If you do this in the calculator, you will see that you will get 28.4%. Okay. So now let's see what happens in scenario 2. In scenario 2, we're going to choose different points. So let me erase this. Scenario 2, they're asking you for the months between 19 and 69. So 19 is right here. 69 is right here. Let's find the slope. So for here, our y2 is going to be 2990 and our y1 is going to be 1352. So let's find the slope. Just plug in those numbers. Minus 1352. x1 69. I'm sorry, x2 69, x1 19. So we're going to have 69 minus 19. And if you do this in the calculator, you are going to get 32.8%. All right, so let's do the same for now for third option. The third option is asking you between months of 36 and 72. So we're looking at 36, which is right here, and 72, which is right here. So now we use the same formula. We're going to get y2 and y1. So we're going to get 31, 35.80 minus 1770.80. And this is going to be divided by x2, which is 72, and x1, which is 36. And if you do this in the calculator, you're going to obtain 37.9%. And lastly, if you look at option 4 here, we are going to see that option 4 talks about different points, which are from 60 to 73. 73 is right here, 60 is right here. So we're going to get 3186 minus 2591.90 divided by 73 and 60. If you do this in the calculator, you're going to obtain that you're going to have 45.7%. So now look at the four options. Which of the following four options has the greatest slope? Well, you can see that option 4 is the one that has the greatest slope. So that means that option 4 is the one with the greatest average rate of change. Okay, cool. Let's look at question 22. It says, which graph represents a cosine function? We know horizontal shift, an amplitude 2, and a period of 2 pi. All right, so let's start with the following. So here we can see that we try to graph a cosine function, and the cosine, whenever we're trying to write a cosine function, when x is 0, well, pretty much for a cosine does not pass by the origin, where the origin is 0, 0. So knowing that, we can eliminate some options here. Notice that here is passing through the origin, So 2 and 4 are not it, because cosine does not pass by the origin, which is 0. So we just with that little statement there, we can just have a 50-50 chance. So now the question is, so let's see, which of the following has an amplitude of 2? So I mean, the amplitude is the highest point. Amplitude is 2. So okay, so that doesn't help us. It seems like the period is what's going to be the determinant if it's between option 1 or 3. Now we know that the period is equal to 2 pi over 3. When we talk about a period, the denominator tells you right here how many times the graph repeats. Over 2 pi, or over the interval 2 pi. Okay, so notice that here we have a 0, and here we go all the way to 2 pi. So let's see, how many times, according to the period, it says here that it needs to repeat 3 times. So we have right here, this is one full repetition. Here's another. Here's another again. So notice that here in question 22, option 3, it repeats 3 times, and that's exactly what we are expecting because the denominator of the period is 3. So that tells you that the correct option is option number 3. Now, if we continue here, we're going to see the following. Okay, so now here in example 24, let's see what exactly are they asking us here. It says a cardboard box manufacturing company is building boxes. Okay, cool. With length represented by, so we have a length of x plus 1, and we have a width of 5 minus x, and the height is x minus 1. Says the volume of the box is modeled by the function below. Okay, so this function, it models the volume. Okay, so now let's see here. It says over which interval is the volume of the box changing at the fastest average rate. Okay, so here, okay, I see. Over which interval is the volume, which we know that this function illustrates the volume of the box changing at the fastest rate. And again, if we're looking at the average rate here, it's the same as the previous problem. average rate, you can think about this as the slope. So pretty much what they're asking you here is find the slope between certain points and let me know which of those slopes is the highest. So let's find our slopes. And again, the slope, you can find the slope by saying y of 2 minus y of 1 divided by x of 2 minus x of 1. But now where are we going to get the y of 1, y of 2? Where are we going to get these values now? Well, we're going to get it from the function here. So now, let's see. In option 1, it says, well, let's look at the interval between 1 and 2. Where the interval of 1, we have 1 comma 1. And at 2, we have about, what is that, like 2 comma 9? Yeah, let's call this 2 comma 9. Okay, so let's look at this interval, and we use our slope. We are going to get y2, which is 9, minus 0. This is a 0. Minus 0 divided by 2 minus 1. And if you do this in the calculator, you will get that is equals to 1, 9. Cool. Now in option 2, let's see. Option 2 is asking you, well, let's look at the interval 1.3 and 5. I'm sorry, it seems like I misread the point here. Is 1 comma 3.5. All right, so let's see again. When x is 1, we get this point, which is 1 comma 0. And when x is 3.5, which is, I don't know, like about here, we're going to get this point, which we're going to say is about 17. This is 3 comma 17. All right, so we got our points. Let's find our slope. So now this, in this case, we're going to get 17 minus 0 over 3.5 minus 1. And if we do this in the calculator, we're going to get 6.8. Now let's look at option 3, which is 1 to 5. So here we got 1, 0 again. So now what happens at 5? We got 5, we got 0, 0. So here we have a point of 5, comma 0. So if we find our slope, this is going to be 0 minus 0 divided by 5 minus 1, which is 0. Okay, perfect. And lastly, option 4. We're going to be looking at, let's see, option 4 from 0, which is about right here. So when x is 0, we are going to get about negative 5. We have 0 comma negative 5. And 3.5, it's about here. So again, we're going to get 17. So 3.17. So if we find our slope, we're going to get 17 minus 5 divided by 3.5 minus 0. And if we do this in the calculator, you're going to get 6.3. So look at the 4 options here. And it seems like when it comes to option 1, we got the highest slope. Or we got the slope with the highest value here. So that means that from interval 1 to 2, that's when we had the fastest average rate. All right, so we made it. We are on the open response questions now. So now let's look at our first problem here. And it says that we need to express the following. All right, so we got this. Now notice here that 1 minus I to the third, this is the same as 1 minus I 3 times. All right, so pretty much all we gotta do is just distribute. So distribute the following. 1 and 1, that's 1. 1 and negative I, that's negative I. Negative I times 1 is negative I. Negative I times negative I. Let's be careful here. So this is positive I squared. So this is the result of the first two, but we still get to multiply by the third one. But now let's stop here and try to simplify here. So we notice that I can combine these two, that becomes negative 2i. But notice here, I squared. And if you remember, I squared is equals to negative 1. This is just a fact. I squared is equals to negative 1. You can substitute with that, so we'll do that here. But now if we do that, notice that this 1 cancels out with this negative 1. So now we have negative 2i times 1 minus I. So if you distribute here, you're going to get negative 2i plus 2i squared. And again, I squared is equals to negative 1. So now we have negative 2i plus 2 times negative 1, which is just going to give you negative 2i minus 2. Now, if you make this your final answer, you will not be fully correct because here it's telling you what kind of format they needed. Your answer needs to be written on a plus bi, which is pretty much saying the complex number, leave it as your second term. So all we gotta do here, just rewrite our final answer. So instead of writing negative 2i minus 2, we can just write it as negative 2 minus 2i, because this is the form that they want. They want the complex number to be your second term. So that's why we have to write it this way. And this is the standard form anyways. You will always write down the reals and then the complex. So this was not that bad. All right, question 26 now. So now in question 26, we have the following. It says an orange juice processing plant. It receives a truckload of oranges. Okay, so the quality control team randomly chooses 3 piles of oranges. Okay, so here's a question here. We need to identify the sample and the population in the given scenario, where the given scenario is you have a truckload of oranges, and out of those truckload of oranges, you're going to be choosing piles. All right, so remember the population is pretty much where can you get all your options? Where can you choose from? And the sample is what you actually chose. So if you want to think of it this way, so here we have a truck. Okay, just use your imagination here. We have a truck here. So we have the driver here. So you have a truck here. Your population is the actual truckload, because whatever piles of oranges you want to choose from, they are going to come from the truckload. So that means that your population is the truckload, because whatever options you choose from, they are always going to come from the population. So now the sample are the actual piles that you chose or you choose. So this is your sample. Sample is what you actually choose, and population is where can you choose it from. We can choose it from the truckload, but at least in this scenario, we chose 3 of them. So that makes those our samples here. So let's just put it in words here. I mean, the sample is nothing more than the pile of oranges, and the population is just the truckload of oranges. And that's about it. So We have identified the sample and the population. Good. So now we read here, it says, state one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. Now, the whole idea of a sample is for you to have an idea as to what is going to happen on the overall. Like if the sample has 5% unsatisfactory, then that means that most likely all of our 5% of all of your oranges are unsatisfactory. Because again, you use your sample to kind of have a prediction as to what's going to happen on the overall group here. So if we know that in our sample 5% are unsatisfactory, then that means that most likely 5% of all oranges are going to be unsatisfactory. So our conclusion is that it is likely that about 5% of all the oranges are going to be, or I'm just going to say are unsatisfactory. Okay. All right. Here we go. Unit circle. So let's see. Question 27. In question 27, we have the following. It says, using the unit circle below, let's explain what the cosecant of theta equals 1 over y. Okay. So now here, we got to remember trigonometric identities. Remember that cosecant is equal to 1 over sine. This is just a trigonometric identity. But we also know that the sine is the y value. In the unit circle. But notice that since or because the sine of theta is the y value, and cosecant is equal to 1 over sine, then we can say that the cosecant is equal to 1 over y. And again, this is the general form. This is saying because the cosecant is 1 over sine, but we also know that sine is the y value, then you pretty much just plug it in y for sine. So now that becomes 1 over sine, which is exactly our conclusion here. So that's pretty much answer this. Like, why is it that the cosecant of theta is 1 over sine? Well, we know that cosecant is 1 over sine, but we also know that sine is a y value. So you just plug it in sine for y. And that's how we come up with the conclusion that the cosecant of theta is 1 over sine. Okay, so now that was fast. Question 28 now. In question 28, we have the following. We have some function, m of t, which represents the mass of radium over a period of time. Cool. So we want to determine the function represents growth or decay. Okay. Growth or decay. Now, how can we find out if it's growth or decay? Well, it seems like this is an exponential function. And because it's an exponential function, it should follow the format of RT. This is just the general case. Now, R is what's going to tell you pretty much are the sides if exponential growth. Well, if grow or decay, let's just put it in simple form. R decides if we are gonna have growth or decay. If R is positive, then we're gonna have growth. If R is negative, then decay. So if we look at the problem here, what is the value of R in our sense? So here, R, well, let's not do that. I feel like the problem is already small enough. Here, R is equal to ln of 1/2 divided by 1590, because here pretty much R is what's on the exponent, which is also in front of t, which in this case is this whole expression here. So let's find this in the calculator, and let's see if it's positive or negative. If that is positive, then it's a growth, and that is negative, then it's a decay. So, okay, so parenthesis, L 1/2, and we want to divide this with 1590. Alright, I mean, we don't really care about the number. All we care about is the sign. Notice that this is negative. So we know that this is a decay. Why? Well, since R since the R is negative, then we're gonna have decay. Okay. So all we need to do is just recognize the format, identify that R is this, have the value, and we saw that it's negative, so that's why it's decay. Alright, so question 29 now. We're going fast now. Oops, we're not there yet. Let's go back. Okay, perfect. Question 29, and it says here, question 29, let me make this smaller so we can actually see it here. So it says, on the grid below, let's sketch a cubic polynomial whose zeros are the following: 1, 3, and -2. Now, one thing that we need to remember is that the zeros of a function are always going to be located on the x-axis. Okay, so let's make our grid. All right, so let's make this straight. All right, perfect. All right, so let's just say this is our grid. This is the x-axis. This is the y-axis. So notice here that they tell you, well, your zeros are 1, 3, and -2. So that means that in my x-axis, I'm going to have 3 points. I'm going to have a point when x equals 1. I'm going to have a point when x equals 3. And I'm going to have a point when x equals -2. Those 3 points are my zeros, and because they are my zeros, then they're going to be located on the x-axis. So now, if you want to sketch, so all you got to do is just literally connect those dots, and you got to connect them in some kind of an S shape, because they are a cubic polynomial. What you do not want to do is connect them like this. That's not okay. It needs to be some kind of a curvature. There is no spikiness here. Okay, so that takes care of question 29. All right, so question 30. Now, question 30 says, given the equal terms, determine and state y in terms of x. Okay. So now here they're making an assumption here. If they are equal, then that means that we can set them equal to each other. So let's just put them equal to each other. We're going to have the third cube of x to the fifth equals y 5 to the sixth. All right, so one is a square root, one is an exponent. Let's just make sure both of them are written in exponential form or exponent form. So we're going to have 5 over thirds equals 5 over 6. All right, so now that we have it in this form, let's actually pay attention as to what we're going to be doing here. Is it determine the state of y in terms of x. So pretty much this is asking us to solve for y. Now, notice here that y has an exponent, so somehow we need to get rid of this exponent. Now, how do we get rid of this exponent? Well, we take the exponent, but not just any regular exponent. We take the exponent of the reciprocal. So if the exponent of y is 5, 6, if we take the 6/5, which is the reciprocal 5 or 6, on both sides, here, this 5 will cancel out with this 5, this 6 will cancel out with this 6, because the rule says that if you have an exponent outside, it comes in as multiplication. Convince yourself that this is true. 5, 6 times 6/5. This becomes 30 divided by 30, which is 1. So that's why they quote-unquote cancel out. So now we got to get... This is extra. This is extra work right here. So now we got to multiply this too now. So now we're going to have 5 thirds times 6/5. If you do this correctly, you're going to get this 30 over 15, which is equal to just 2. So that means that we're going to have x squared equals y. So this is your answer. You solve for y in terms of x. This concludes part 3 of our Regents review for the January 2017 Common Core Regents.